Welcome to this hands-on guide for Docker on the Raspberry Pi. I'm your Docker captain Alex Ellis, and this accompanies a blog post getting started with Raspberry Pi. We're going to flash Raspberry into a fresh SD card, install and optimize Docker from scratch using a single command, and then we'll run our first Docker container and we'll have a look at some of the concepts and how to manage containers. We'll then play with GPIO by creating a program to activate a buzzer, and we'll go on to create an internet doorbell with Python and Flask that you can access in a web browser. Let's get started. Let's take a look at the list of disks on our machine. Right now I'm using a Mac Mini. This would also work exactly the same on a MacBook Pro, MacBook Air, etc. So right now I can see dev disk 0, and that's quite a large disk. That's my system drive. The one thing I don't want to do is overwrite that. So make a note of that drive now. I've just inserted my SD card and I'm going to run the command again. And we now see that we have a dev disk 1. And in this instance that happens to be the SD card, and it's got a corresponding size to what we were expecting. What we need to do is go into the folder where we've downloaded the Raspbian image. As you can see here, I've got Jessie Light, and the command we'll use is dd, but it needs super user privileges. Input file is the image, output file, and this is where we've got a neat trick. If we put our disk 1 instead of disk 1, we'll get a bonus in speed, and then we want to specify the byte size of 1 megabyte. So one thing you need to do is eject the disk and mount the disk without ejecting it. So we're going to unmount it, and you see the boot icon on my desktop about to disappear. And then we run in the dd command. This could take anywhere between 30 seconds and sort of 5-10 minutes, so we'll come back when this is finished. As you can see, that's taken 130 seconds and my 8 gig SD card is now populated with Raspbian. I'm going to eject the disk. And once it's safely unmounted that disk, I'll plug it straight into the back of the Raspberry Pi Zero that I have in my hand. This is what my Raspberry Pi Zeros look like. So I've got the SD card, putting it into the Zero. At this point you'll also see a white USB connection on my picture. That's actually a USB Ethernet adapter. And what that means is that the Raspberry Pi won't need any configuration for Wi-Fi. You can simply plug this in just like this and put the power. Now in about 30 seconds I should have Raspberry Pi on my local computer, on my local network, and it will have the name of raspberrypi.local. The username is pi, and we'll be able to use SSH to reach it. This will work on your Mac by default. So we can have a look and see whether it's there yet. Looking like it's on the way. So Raspberry Pi now has an address of raspberrypi.local. If you plug in two at the same time, they will obviously clash. So the first thing I recommend you do, password here is Raspberry, is is to go in and change the host name. So we type in sudo hostname learn docker. We also need to populate this in 2 other files. So over here in etc hosts and in etc hostname. This point in time, we could probably do a reboot of the Raspberry Pi, but there's a couple of extra optimizations we can make. Because I'm going to run this Raspberry Pi without a monitor, I'm going to go ahead and take away most of its graphical memory. Go to the absolute bare minimum, which is 16 megabytes. What that will do is enable us to have more available for Docker. So I'll do a quick reboot so that I get the new name, and then we'll go on and install Docker with this single command. So the Raspberry Pi is rebooted and it has its new host name, and we'll be able to access it as pi@learndocker.local. Password has not changed. Now, if you don't like typing in passwords, you can use SSH copy ID pi@learndocker.local, and that will allow you to cache the password, and then every time you try to log in, you see that the password is not required. So there's a single command to install Docker. Once we run this, we will have Docker. Probably take a couple of minutes, and it will go ahead and fetch the latest version for Raspbian. Now Docker does work on other distributions, but the most official effort at maintaining it is currently for Raspbian, so I'd recommend going ahead with that. Once the installation has finished, in order to allow the Pi user to use Docker without sudo, we should add Pi to the user group of Docker. Now, just while that's installing, we'll talk about base images. There currently are no official images for Raspberry Pi provided by the Docker project. There are some that are halfway to being official, maintained by a Docker employee. Now they are under the HF prefix, which you'll find on the Docker Hub. So here's an example of Node.js, and there's a bunch of other ones. Now the image that's used to actually build Docker for Raspbian is Resin's image, and that's what we'll use in our example for our first image. I've used this for all the images I've built, and it will be the most familiar experience as a Raspberry Pi user, so I would suggest using it too. Let's come back when this is finished installing. Docker's installed. We're now going to go ahead and enable Docker for the Pi user, because right now we won't be able to access it unless we use sudo. So we use the usermod command, and then we have to log out and log back in again. Now if you used SSH copy ID, you won't have to keep typing in your password. So we can now look at the Docker version that we have installed, which is actually the latest release, which is great. This is always up to date, and then we can try to pull down the Resin image. For Raspbian. Now all the layers will be pulled down from the internet, and then they'll be extracted. This can be quite CPU intensive for the Raspberry Pi. It's a bit quicker on the Pi 2 and 3. This is a 0, so if you bear with us, I will go over to another Raspberry Pi that I've already prepared. So if we type in docker run resin Raspbian latest, and we start bit in bash, we'll find that we're now actually in a container. It's got its own host name, and it even has its own file system. Anything you do in this file system won't affect your host. So if we create a new file in the root, that will not have affected our host system. In effect, this container has its own view on the world. We type in Python, we'll say command not found, even if it's installed on the host. Now, what that means is that you can go ahead and build images for any kind of software you want. And fortunately, you can actually use apt-get here. So this should get us Python. And so what's happening now is apt-get is going off to download the Python packages. In a few moments, we'll have Python available and we'll be able to start executing programs. Now, the step that I just typed in is a manual step, but this can actually be put into a file, almost like a make file. It's called a Docker file, and from there we can pick what software we want, and the container will only have the minimum parts that we need to do something useful. An example, in the Getting Started guide, we install the curl utility, which many of you will know can be used to fetch a resource over HTTP over the internet. So let's take a look at how that would work. What we'll do is make a folder, curl demo, and create a Docker file, paste in the contents, and at this point in time curl would be fine, don't need anything else. And to build that, let's see if we have the instructions here. You type docker build /t and then the name. The colon allows you to give a tag, so it could be, let's say 0.1, docker build curl demo 0.1 in the current directory. This will go off to the internet, it will run apt-get, and by the end of these steps we'll have an image which contains curl, and as soon as we run it, it will go off to docker.com and bring back the front page. In the meantime, our resin image is still extracting on the Pi 0. Now I've made a couple of changes to the Docker file. I've overridden an entry point command which was baked into the resin's Raspbian image. What that means is that it can interfere with the command that you've set to start up on the container. This just makes sure nothing can interrupt it from the parent image. And then to the curl, we're passing S and L so that we can use SSL certificates, make sure we're actually accessing the correct website. So we'll do a build, and you can see that for every part of your command you should put them in double quotes with a comma. Not everyone knows that when they start off. And now we'll do docker run, and it will run the CMD that we had baked into the image. Now there's nothing to stop you from typing in something else at the end of this, blog.alexellis.io, which isn't running with SSL, and it's actually gzip format, so it looks a bit strange. But if you were to look at the headers, we'll see some extra details about the block there, and the fact that it's gzip encoder. In the tutorial, we look at creating a GPIO program which will flash an LED on and off. We connect the negative line to ground and the positive line to GPIO 17 through a resistor. I've made a modification to that program such that I've connected a buzzer between these two pins instead of a red LED. Code is pretty much the same. It also prints out 1 and 0, although you will definitely hear this as soon as I run it. So be prepared for a loud buzz. Now that's running the application with Python on the local Raspberry Pi. What I'm going to do is create a Docker file. The first thing we do is we go ahead and pull an image that I've already created. Now this is the base Raspbian image with Python installed. If you look up a little bit in this tutorial, it will show you how to do that. You can use my image, and then I'm overriding the entry point from the parent just to make sure there's no side effects here. Having a work directory of the home directory of the root user, copying in app.py, which is our source code, and then the command, which is the piece of code that's written as soon as we launch the container, is just to literally start that program with Python 2. Again, we'll need to do a build. So let's build this, give it a version. And if we already have this image, we don't already have that image. So what will happen is Docker will go ahead and download that. I think we already have this image, which is the same except it has pip installed. No, okay, so we've got to wait a couple of minutes while this image gets downloaded to our Raspberry Pi. The basic steps that I've installed you can see here, which are to install Python directly from apt-get. Our Docker image has now been pulled down for Python 2 and all the requisite steps are being run in. Now the last step there is telling Python 2 to open up our application code. And each of these intermediate lines that are in the Docker file at build time are actually running their own Docker containers. So if you have a whole bunch of steps that you want to run in or that make sense only when they're together, you may want to use this and backslash separator, which means that these will actually be run in one whole step, and if any part of this fails, it will all be running again fresh. So we've built our GPIO buzzer. Let's try and run that using -ti to attach a console, because this is going to start buzzing and we want to cancel that pretty quickly. We also need privileged access to memory because we're using GPIO. There is some discussion about that, which is probably out of scope for this video. And there we go. We got exactly the same behavior as when we were running this through the host. If we look at Docker PS, we won't see anything. We do ps-a, we'll see the container that we got created, and any changes you make in that container will stay in there. And if you want, you can restart a container that you've already stopped, and you can attach to it and you can run stuff inside it. So just be aware that as you're running the containers and stopping them, Docker PS will not show the ones that you've stopped, PSA will, and so in this instance we actually probably want to get rid of that, Docker RM. Now if you don't like working with these IDs, you can actually assign a name as soon as you create the container. and now we can use that name to get rid of the old container. Okay. Docker images will show us all the images that we've built so far, and so we've now pulled down a base image. We made some changes inside it which weren't replicated in the host, so they were completely contained. We've pulled down an image that contains Python 2, and we've created a simple buzzer application in Python that we've run there. What I now want to show you is how we can combine that buzzer and a simple web server in Python Flask to create an internet doorbell. Now, there's a full example of this code for a flashing LED here, and what I've done is I've just quickly adapted this code. This is a template for a Flask application, and I'm running that in on the Raspberry Pi right now. What that will enable us to do is every time someone hits a website, the buzzer will beep for a set duration. Now, this is a new command for us, expose. Expose tells the container that there's a port that we need internet access on. And as soon as that is ready, I will open another terminal over here and get ready to type in the curl command. So we can still use the name, the network name. This is going to be on port 5000, which is just where Python Flask runs by default. So we'll type in docker run. We want this in a privilege mode to access GPIO. We need a port available 5000, and then we want to attach the keyboard so we can come out of this. Container's now running. We have a web server, and over here on the other side I'm going to enter the curl command, and you can see we have doorbell rings 1. The internet request is displayed here. Run it through again. So you can imagine giving this URL to a friend and then wanting to access it. Right now that won't work because this is hidden behind our firewall and our ISP. There's a neat program that you can use to very quickly expose that service called ngrok, and there's also a version for ARM available for this for the Raspberry Pi. So if you run this program, what it would do is open up a hole to the internet, and if you give anyone the URL, they'll be able to go along in a web browser and they will be able to access your site for as long as you've got that program running. Here we go. We can even open this in Safari. I'm just going to share the Docker file with you here and the application code. Feel free to take this as a template and modify it, and I'm happy to take questions, comments and suggestions over on Twitter at AlexEllisUK. Thanks for watching.